All right, guys, we're back with the JD's Garage CNC plasma table. Guys can get a closer look at the water table itself. I wanted to go over a couple things. So I went to Fazio's and we bought this this 1/8" flat stock here, which worked out really good. And I made sure it's 2-inch flat stock, and it just comes right above the pan right here, which is nice. And kept it really simple. We just cut them the length of the pan, and in this case we can measure it live right now. I got my tape here. There's another project we're working on. It's a 09 Vulcan 900. It's got some starting issues. But here's our pan. Some of you were looking or asking some questions about it. And here it is. So we built the table according to the JD's Garage plans. And there's our measurement right there. It's about 54, yeah, about 54 inches. But look at our clearance from the bolts. We got about a 1/2 inch clearance down in there. So it's 54. By 60 by 5 foot. So the reason why we went this far is I'll show you guys in a minute. And I'm going to get this gantry. We're going to bring it all the way back here and you guys will see. So we should be hooked up right now. We're going to do a quick homing. Let's see how that works out. I got this metal bent up here for the ground. This might hurt us. So let's see. Let's push that down and home the machine. So everything seems to be working pretty good, pretty smooth. Again, you got to home this thing before you get started. If you don't home it and you start the program, it's gonna, when it gets to the end, it'll start slamming up against the end. So make sure you home your machine before you start your cuts. So let's go to here. Go to continuous jog. And we'll run the machine back here. Now, I haven't been typically running the machine that far. Yeah, because I have my ground hooked up. But the reason why the pan is this big, some people would say, well, why didn't you take the pan all the way to here? Well, this gantry here is only going to go back so far. Once it hits here, it's done. And you have to control how far that goes, right? So what we're going to do is we're going to add limit switches. We're going to daisy chain these limit switches here. We're going to come off of that. We're going to come to here, put another limit switch in. So this way we can control this and it'll stop this motor on this side. Same thing with the other one. We're going to get that. We're going to put another limit back here. I don't like not having the limits on both sides. I like the fail safe that if it does go too far, it'll shut down. And the reason why I say that is if you load a program in here and you're not paying attention to the inches, especially when you transfer, when I transfer from Inkscape to SheetCam, and then you export it and bring it into Open Build, if you're not keeping a close eye on things, and you run it in Open Build and home the machine, you'll see you'll see this thing, and I have done it. You'll see this thing just take off because maybe the starting point might be on the other side, and the machine will just slam up against the end, which is no good. So I think on this bigger setup here, even on much more high dollar machines, I don't see limits on both sides. You should have limits on both sides. This is cool, great for homing, great for setting the limit on this side. I think it's more for homing than anything. Because if it was really for limiting, you know, you can limit this side, but really you need to limit that end of the gantry too. So this also needs to be, so we're going to get a wire. We're going to chain these together. It's going to go in here, that way, boom. And if any one of them trip, it's going to cut that circuit out. It's very easy to do. So we're going to order some more limit switches and we're going to get that done. But I'm getting kind of off topic here. So this is the water pan. Turned out really well. I kept it really simple. I cut blocks of wood and I spaced all of these the same way. Just because I like it nice and uniform. Does it need to be like this? No. Is it the best setup? No. You can do, you know, you could space these to where you could bend them. So you could space the middle. Some of them like them arched. I guess because of the way they cut. They don't want the cut landing on the steel straight all the time. Another way I was thinking about doing is actually on a diagonal. Going this way. Which would have worked out even better. So if I do end up replacing the slats, which I don't see myself doing at any time in the near future, unless I really start getting requests to make pieces. Excuse me, I'm all congested. So, but this works just fine. This is 20 gauge galvanized sheet metal. You can see the end of it is hemmed over. You know, obviously you don't want a raw edge of steel here at 20 gauge. It gets sharp. The corners are brazed. They were brazed in the shop and sealed up. The guys did a great job fabbing it up. They're the same guys that fab our plenums and ductwork and things like that. The thing is really flat. I leveled it. My garage is a little off. So I have like 5/8 piece of strip here on the side where it falls towards the garage. Again, these casters work great. I can move the machine around anywhere I want. It's doing its job. I end up putting the plasma cutter back on the side here, off the ground, out of the way. Again, getting back to the water table, you could see here that we have, I think the measurement is 3 inches. From the edge. Yeah, it's about 3.5. So that's about as far as we can go with starting a cut. So really, the farthest we can go is about 4 inches. And the reason why I did that is I wanted the pan to come as far to the edge as I possibly could, because I know once the, you know, plasma cutter goes on and it starts spraying air out, then we're going to get some splashing. And I wanted that splashing to happen inboard. You know, manage it as much as I can. And it works well for what I'm doing. And for the most part, I've been cutting on this end of the table because nothing has been, I'm still not 100% confident that I can put a big job on this table and have it stay consistent, right? You still have to monitor it because you have consumables. You always have to keep an eye on it. It's not like you put it on and let it loose. And if you do, it's probably going to be for one project. And if it's intricate cut, then you're probably going to change the consumables before you get started. And then most likely after that cut, you're going to be done, depending on how everything goes, right? So one thing I did do, let's stay on the topic of the table, I'm sorry. But if we look underneath, we have a drain with a PVC valve there. And I had my bucket underneath of it. This is my bucket. Things got moved around a little bit when I took the car out and put the bike in. So let's take a look here. See what's going on. All right, we had a little drip there. A little bit. So I just added water to the pan. And I did use the green fluid, and I used a gallon in here. And I added 20 gallons of water. So one gallon got me this table full where it is, you know, up to the top. And that green stuff, which I think that's what it's called, green stuff. That's the right mix. It's a 20-to-1 mix, I believe. Yeah, it's 20 gallons to every gallon. And that worked out well. And you could keep adding to the water's going to evaporate. And then you could just keep adding water. When it gets really diluted, then you'll have to add. So let's get under the table here. Take a look at what I did. So this is just a standard sink strainer that you would see under your kitchen sink. This is the tailpiece. Same thing that you would see under a sink. And this is the trap adapter that you would typically see on the going through the wall where the trap would connect. And I did it this way so I can hook up the strainer. And now I have a valve here, and here's my bucket. Now, the plan was to, I have a 5-gallon paint bucket screen. They're kind of throwaway. You just stick them in the bucket. You can turn this on, and the water and green solution will come through, filter through that screen. I could take the screening out. That'll take out all the garbage, and then I'll be left with the green solution in the bucket. I'll close the valve, go up top, pour it back in, and we're good to go. We're back in business. If you look at the underside of the table, there are breaks from the corner to the center, from all the corners right to the center. That's purposely done, you know, because I had the slats sitting flat, and this will ensure that everything, you know, drains to the center and everything gets evenly distributed. You can see I put a couple pieces of steel here, one here, just as more support in the middle. And so far so good. Haven't had any issues. Looks like yeah, that's pretty good. I probably got to tighten this adapter here. I've been moving stuff around the garage, and I probably bumped it. So, I'm going to give it a... I want to show you guys what I cut. So after we did the grounding and grounded these parts here, you know, back to the ground rod, we did a test cut on something a little bit more intricate, a lot of cutting, and that part is right here. This is it. And I thought this came out really, really nice. This could be used as a venting, drain cover, or an air vent, anything like that. Or just a decorative piece. But this came out really good. This is the top side of the cut. I made a boo-boo there. That's my mistake. This is the back side. There was like nothing on the back side as far as slag. It was very easy. I just went over it with a scraper, came right off, and then I went over this with a scuffing pad on my die grinder, and it came out really well. And this, I had no hiccups at all. This came out perfect. Perfect cut. Another thing I did was I went with a 0.9 tip with this plasma cutter here. And those are the tips that I found at Harbor Freight. They seem to give me a much more detailed cut. And I brought the air down also to only about 50 psi. And that seemed to make a big difference too. So we're going to see here. I have a quick address sign that I made up. And I have this piece of steel left over. I'm going to try to cut it out of this piece of steel and we'll see how it goes. All right, so we want to cut something here. We want to cut a sign. I put this together. It's an address placard. But I seem to be having some trouble. So I'm using Inkscape to create the signage, which we can go to here. And we can see I created the sign. When I click on nodes, I have reduced the quantity of nodes. Okay, we don't know where. There we go. All right, so we go up here. We go to nodes. And there was a whole lot more as far as nodes in here. And I've reduced it as much down as I can to smooth the machine out as it goes around these cuts. So I did all that and I exported this file. Came over to SheetCam and it looks like it smoothed everything out pretty good. You know, when I run the simulation, I start it, it looks really smooth. You can see it here, runs around. We can speed it up a little bit. And you can see it runs, looks like it runs through the cut smooth. And I would expect the machine to do the same thing, to run through these letters nice and smooth. The same way this simulation is doing. And that looks good. But when I pump the information into OpenBuild and I run the job, you can see this. And it appears that all of the blue is smooth. But when it gets to this red portion, it's like it's hitting all these nodes. And I'm not sure how to smooth that out, or if it's a product of how or what processor I'm using. I mean, it looks smooth here, but you could see when it hits the red, it's jerking around. And I'll show you here. So we're running it dry right now. So you can see you get it smooth. And then it gets to that like jerking motion to where it looks like it's picking up every node that I'm pretty sure I deleted. And again, if you look here, the blue areas seem to move pretty smooth. And then we're on the red areas. They seem to stop and kind of jerk around. Like it's going through every node. So we're going to plug this in and see what kind of product that we get out of it. And more importantly, we want to make sure that we're not freezing up. So I have everything set right now as far as where the piece of steel is going to stop and start. I dry ran this a couple times to make sure that the torch is on steel. So here's our cord, our 220 cord. And this is a heavy gauge cord, but it has a standard plug. And I have a 220 plug here, which I can now plug this into. And you have to remember that it's 220 and don't plug anything 110 into it. Our compressor we're going to keep off because we're sharing this line as of right now. So we load the air compressor, we shut the air compressor off, and then we plug in our 220 line there, and then we're hot. Now we can turn our plasma cutter on. This should already be set from the last time. I have this running at a much lower pressure. It seems to like it with the tip that I'm using. I did not change the, we're sitting at 40 amps, and all that seemed to be good. So let's give it a whirl, and I'm pushing this a little bit more now because I'm running it off of Bluetooth. But now normally when I run, I don't have the internet up and running. So you know what, we'll disconnect that for now. And let's run this and see what happens. Let's see our battery. Our battery's full here, so I'm going to pull the charger off the laptop. Any other functions, USB, I usually take off of the laptop, so there's nothing plugged in. There's nothing else running right now. So right now we just have our ground, sheet grounded, and let's give it a go and see if everything that we've done as far as grounding. This right now is just a product of trying to figure out, I hope you guys can help me figure it out, how to get this to smooth cut. And I guess try to understand, or maybe what processor I need to be using. Right now I'm using the gerbil plasma processor in sheet cam, which is, we could bring it up here. So when we go to options, machine, post processor, I'm using this processor right here. So initially I was using the one that was given in the JD's garage, which was the Scriber. The edit, here it is. I was using this one here, and that seemed to be doing some funky stuff. And it wasn't working right with my file. So I'm wondering if I should be using, because in sheet cam this thing is flowing nicely, really nice. So we'll stop this so we don't have any background functions going on, and let's see if we can make this happen. I'm just going to check for some moisture. It's been pretty dry in here. So we have our separator here, goes through our line, comes down. We have another separator here with desiccant in it. And then we have another separator here, which is bone dry. No issues there. Yeah, let's fire it up, see what she does. Hopefully, yeah, let's run this. Make sure we got our torch plugged in, which is in here. Good. And yeah, let's give it a go. them nice. That's the kind of smooth we're looking for right there. All right, let's take out our cut. I mean, I can deal with this. This is pretty awesome. I think we're moving pretty quick. All of this stuff is popping out. Let's see what we got here. Looks like we cut all the way through. Woo, right there's a little hot. I should bring the water up a little higher here. Definitely. Because we can definitely get a little better. Yeah, it's hot. Woo. I gotta bring that water level up here. There we go. But the cut is just phenomenal. I mean, guys, this is a different table now. Totally different table. So here's the issue that I'm having. On the clean cuts, the ones that go at the speed they're supposed to go, they're nice. The cuts aren't bad. The face of the cut is really nice. I am not complaining about that at all. I believe that this stuff can get knocked out fairly easily, but I am trying to understand why you know, I'm having why I'm having the machine, you know, jolt around the way it is. The face cut is incredibly smooth and clean. No doubt. No issues there whatsoever. Very clean. But again, I don't know why it's picking up. It seems like it's still picking up the nodes that I got rid of. You know, this is, and where it starts to jerk and kind of trying to pick up every node, that's where I'm having that buildup of dross on the back. You know, that's what's pretty much holding this together right now. The cut itself, the face cut, the back side, it is, you know, the face of this is just unbelievably smooth. Even though it jerked around, it's still super, super detailed, as you can see. But we can definitely do better. This is all the dross on the back holding us together. That's what that is. That's all the garbage on the backside holding this. Yeah, here you go. Look at it. It's kind of mending it, not mending itself together, but I guess you could say it is. You know, the spots, especially here where it's, you know, it looks, it's jerking, like it's hitting every node. Doot, 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 doot. That's where that's happening. But I'm pretty confident, like, see, even this stuff here, we can knock that off. Let's get our, I don't know if you guys seen these, but these are throwing axes. These are nice. Look at that. I mean, with really minimal effort, I can take all the dross off. Oh, even on here. So let's try that little technique there. Let's take the dross off. I may rename these my dross hammers. Oh, look at that. That came out really, really good. I mean, even the back, the dross is a joke. You know, once it's off. Once it's off, it's just, it's awesome. The cut is just great. You know, I'll show you a spot or two here. You know, that's coming right off. And we should be able to knock these letters out a little easier. I don't have two hands right now, but pretty sure we'll get a little up close here with the actual cut. But look at that, it came right out really nice. This looks really good. I mean, as far as the machine is concerned and the issues that we were having, they are gone. And if you watch my last video about the grounding, that grounding completely changed the table. If you guys paid attention how consistent the plasma was, there's no fluttering, there's no BS. It's very consistent, very strong. And I felt like last time I was trying to compensate with more air and more amperage and try to get a cut done. But really, this all stemmed from the grounding issue. The plasma cutter itself is much more consistent, stable, and concentrated it's more powerful because it's not fluttering or, you know, blipping or any of that crap. I really need a stand here where I can get you guys set up. You know what? I'm gonna knock these out. I want to get my hand and screwdriver and just push these out the rest of the way. I don't want to do it on a table with one hand. I'm afraid it might go through the table. But let me pop these out, and then we're going to get up close with these cuts here, and I'm going to show you. I'm so happy with the way this came out. Let me pop these out, and I'll get right back. All right, guys, we're back, and I finished knocking out the inside of these letters here. And just like I was saying, the dross on the back, because of that, we can't get a really smooth movement around these letters. And I'm pretty sure there's either a step I'm missing or I'm either using the wrong processor to make these cuts seamlessly smooth. Once I get that figured out, this is absolutely fantastic. Now, you guys seen the machine in action. This is our second pretty intricate cut since we did all of our grounding and EMI mitigation. So I think I showed you guys this already here. This was the piece I test ran, and this came out, I mean, in my mind, compared to where we're at, flawless. This little hiccup here, I did this. I tried to reposition the machine and do a little cut. I did that. I messed that up. But this is awesome. This came out great. The dross on the back knocked right off. Very minimal on this. The difference between this and this cut is these little squares. This is something I downloaded offline. And however way the file was, it was very clean. Now again, these aren't curves and stuff like that. So this is a node, that's a node, this is a node. So it's literally node to node to node to node, and it just goes around. Squares are a piece of cake. Straight lines, this machine can do it all day long. And I'm very confident now after doing this. And I picked this lettering specifically because it had alterations in, it has curvature. If you guys can see it, it curves. It's wider, it's narrower in some spots. And I wanted to see if I can get all that detail done with our setup here. And I am 100% confident now that after we did our corrections to our grounding, we are in fantastic shape. I hope you guys followed the last video. It is an absolute game changer to this table. Sky's the limit now. Now we're just going to be improving on, again, setting up. We're going to get some new limits, and we're going to add them. We're going to put limits here. We're going to put a limit here. And we're going to put limits on this back side here. Boom and boom. And we're going to make this table bulletproof. This is going to be fantastic. And it's great already. Again, let's show you this cut a little bit more in detail here. This is the face of the cut, looking down the side. Look at that. Super flat, super clean. We have our temperature right. You don't see any bluing going on anywhere. So our temp is right. Our speed is right. Our flow of the cut is not right. And the flow is what I mean is like we got to smooth out the movement and I'm pretty sure it's a product of the processor or me missing a step, maybe an Inkscape. If you guys know, let me know, please, because I would love this thing. If we could smooth this out, it would come out with no dross on the back, with little to no dross on the back. This does have dross on the back, and because of it sitting on the nodes and moving very slowly, the heat stays there a little bit longer. We need more speed, and the dross itself ends up closing in on itself. That's why I had to knock these out, the remaining of them, with the hammer. But the rest of this stuff, once it's knocked off, it is as flat as could be. It isn't a choppy cut. So you can see the F there. Once I didn't knock everything off, but you could see where it was picking up those nodes and stopping and starting, like here, boop, 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 boop. It would come to the corner, boop, 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 smooth transition, boop, 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 boop. And then again, smooth around here, smooth around here. Again, with the A, really smooth. When it's capable and able to move at the speed that it's set to, and if we can get it to flow through these circles or radiuses without chattering through all the nodes, which I still can't understand why, because in Inkscape, I purposely went in there and I eliminated a lot of nodes that were in this drawing. And again, I am not complaining at all about this. This is a fantastic cut. This is a legitimate sign that we could sell. We can create different signs like this with this font. Again, I chose this font because it was much tougher than your standard straight stuff. So let's put a little contrast behind it, and let's see what. Oh, look at that! So we backlight this. This is a great sign. This is a beautiful, smooth sign. Look at that. That is a great sign. That's just. It only gets better from here, in my mind. In Inkscape, I was able to place these holes, you know. And, yeah, there must be something, a step that I'm skipping or missing to really smooth these cuts out. When I say smooth them out, the cut itself is ridiculously smooth. Look at the edge of that. On a straight cut, look at that. On a straight cut, you can see in there inside the A. This thing is just incredible. You know, I got those parts initially from JD's Garage, and their parts came out looking like this. And I looked at it and I said to myself, there's no way they're cutting this off a plasma cutter. But now, after seeing this, you know, there's not much pitch on that. Very little. Again, same thing there. That's pretty square. Same thing down there. Pretty square. But look how smooth the cut is. Look at that. The speed's correct. The heat's correct. The air is correct. The dross on the straight cuts is literally nothing. And we got us a killer custom sign right here. We can make these all day long and pretty much print money, in my mind. This is a great sign. I don't see how someone wouldn't want to pay for this. You know, we can add some more detail to it. We can backlight this. We can create a box for it. We could do contrast. We could do infill. Like, I can pour color in here, you know? And really, like, if I poured color in here, like a ceramic color, with a contrast color, you know, have this, say, black or whatever, or even roughed up and glossed with a color infilled in this, this is a bulletproof sign. This is going to last forever. I mean, 1/8 inch steel, who's not gonna want this? This is a great cut in my mind. Guys, mission accomplished here. I hope you guys watched my last video. I wouldn't even have gotten, I would have, by the time I started the first hole and the spark the next, for the next letter here, the torch would have went out. The program would have froze a million times. It's come a long way. The grounding is a must, absolute must. You know, and this is just a lot of fun. This is a lot of fun being able, having this in my garage, you know, for the price that it cost, which in my mind is basically nothing, compared to what you're getting. The things we've cut out of it, you know, stuff like this, you know, stuff like this. I initially cut these out when I started, and I was having some hiccups, the same hiccups that I was telling you I was having with the freezing and whatnot. We managed to get through these cuts with the starting and stopping. You know, we cut a lot of stuff. I mean, I've cut a lot of stuff on this thing so far. You know, we got our trailer hitch emoji here. That's gonna go, we gotta drill the hole in there. That's gonna go on our truck once it's painted yellow, along with these guys here. These are really cool. These are actually really cool to put in the window behind this shade, and it actually makes a silhouette. You could actually see the guy's face. You know, other things that we cut was the monogram. That is just going to improve now. You know, this was probably one of my favorites here. We cut this out of a piece of scrap stainless that we had sitting around. That's our Ford sign. That cut, this took a long time. And this sign should literally take, because it's so thin, we could speed it up to 150%, and we can rip through stainless steel. You know, this is very thin. This is just a shelf I had laying around, and I decided to cut this out from it. But the start and stops on this was ridiculous, and we're not going to have that problem anymore. That is out the door. We got us a whole new table here, and it is kicking butt. I hope, like again, I'll say it again. I hope you guys watched my last video. This is spectacular. If you do know how to stop or prevent the machine from hitting all those nodes, or somehow smoothing it out to where we could just get the machine to just flow through the cut, you know, much smoother, this would literally be no prep work. These letters would fall right out. The dross in the back would come off with a scraper. These here, look at this. There's nothing on the back of that. I took that off with a scraper. You can see I didn't sand or wheel anything on that. That is good. That's ready to go out the door. And this is another, another reason why I'm cutting these round circles and all these different angles, because I want to challenge the machine. And I want to make sure, if it could cut stuff like this, and especially stuff like this, this is always changing, in and out and all over the place. And to come up with a product like that, that is really good. I know we can cut parts on this thing. I know we can do cut lines. We can make pieces all day long on this machine. Because like I said, I cut the JD's Garage cable chain holder, which I haven't put on yet, which I don't know if I'm going to because it's a bit heavy. I might cut it out of aluminum now that the machine's running right. But this, you can make parts like this all day long. Like this is, you can go into Auto or FreeCAD and you know, design them. This was basically designed as a flat piece. You know, this was all flattened. You put your cut lines in it, and then or bend lines, whatever you want to call them. And you got yourself a nice enclosure if you want to make an enclosure, or you need to make an angled piece. You know, whatever that may be, you can get it done on this table. I know there's people out there that are having problems with the table. I know there's plenty of people bad-mouthing it, but this is easily correctable. It should happen with any table out there. And as you guys can see, there was a lot of fumbling in the videos prior to, with me stopping the videos, trying to figure some things out, and why, you know, stuff was freezing or I couldn't get through a cut. I think we're past that now. Now it's just a matter of fine-tuning our skills on the design and getting things to flow. But this is going to be my address placard here. I think my wife's going to really like it. I'm not sure where we're going to mount it yet, or what color we're going to paint it, or if we're going to paint it at all. But I'm really, really happy with it. And this, I was able to size this to utilize the piece of steel that I already had left on there. So just to give you guys an idea, I paid $100 for a sheet, a 4x8 sheet of 1/8 inch steel. I have cut, now I still have a 4x4 sheet in my shipping container. I've only cut one 4x4 sheet. I've cut all this stuff out. This, that, this, that there. The monogram I cut out of it. I cut out all these brackets here. These were 45-degree angle flat brackets that I cut out for a gazebo. I also cut T-brackets from the scrap pieces as well that we used on our chicken coop. That's what this was for, these angle brackets. We made a octagon style chicken coop, and with 4x4 base, and then these were the attachments, the steel attachments that I used on the angles, which worked out phenomenal. And there's still little pieces left to spare. You know, I don't want to throw them out because I know I can use them for something. So for $50, I have cut, so each one of these brackets here, if you were to buy them, I think they were almost like $10 each, and they're not out of 1/8 inch steel. So 10, 20, 30, 40, 50, 60, I cut 8 of them out. That's $80 right there. You know? We got signage we could sell. These are gonna, I'm pretty sure these are gonna sell pretty good. This is gonna be a cool product. I like it. I hope they catch on. You know, these faces, these parts, the address placard. I'm sure there's other stuff around here that I cut. just as like a, you know, like testing. So there's this here. I'll show you something else I cut here, which was really cool. And I took a tip from JD's Garage as far as, so this is another piece of 1/8" steel that I have here. This is going to go inside the fireplace. Air is going to come in through the bottom. But I didn't have a piece of square tubing to make the center here. So I cut a long flat sheet, and then I made relief cuts in my design, and I only left a little bit on each corner. And they were basically bend lines. And I was able to bend this into a square, weld the corners. I actually TIG welded them, pretty sure. Yeah. I TIG welded the corners, and I TIG welded it down to this plate. And now this plate is going to sit in here, and then this is going to be a burner, the inside of a burner, and we have to create another outside ring. But this is just some of the stuff that you can make, you know, on this table. Projects that would take you so much time to do. You know, once you get yourself used to dealing with these programs and figuring out how to use them, you know, you're off to the races. You could build whatever you want to build. You could fabricate if you come up with an idea for a tool, or maybe find a part that isn't manufactured anymore. Or maybe people have to rely on junkyards to get certain parts or pieces, especially like in my case, OBS parts, the frame portions like transmission cross member. I can easily come on here now. I can go in the FreeCAD, take the measurements of the existing brace, go in the FreeCAD, fabricate that same brace, you know, design it. I can design it even nicer. We could put Ford logos in it and everything. And then we have a legitimate part that people are going to buy for like the restoration of like OBS Fords. That's just an example. It could be for Chevys, could be for whatever. I know there's a lot of parts out there that people can't get when they're restoring cars. You know, and you can carve yourself out a little niche there and be that guy. Or people could send you like, you know, parts that are, I guess, rotted, or they're unable to support things. And then if you could replicate them on the table, do a little welding, you got yourself a pretty nice business. I think you can make money with the table, and that's what we're going to try to do. And try to do some marketing. I think these are really nice. These are going to be really cool, especially if we can incorporate these somehow into like a mailbox, or we can do an upright. You know, people could stick them in the floor or the ground. We can do a wood accent trim out. We can do AZAC trim out, you know, just for longevity. A lot of things we can do here. I can pour this, which I might get a little crazy and do that, you know, because I have a little smelter, you know, furnace right there. And I poured some copper bars at one point, and I could really see this being, like, you could pour the copper and inlay this, and you could really sell a high-end product. You know, I'm super pleased with this. I'm really happy with the way things turned out. I'm still gonna get the enclosure, but I was kicking around, and let me know what you guys think of, you know, I have a sheet of 4x8 aluminum that I picked up from Fazio's. I haven't cut into it yet, but I was thinking about designing an enclosure, an aluminum enclosure, with the relief bend lines in it, something that we can cut on our tables, and you can literally fold up and make yourself a nice enclosure out of aluminum. So I think I may attempt that. And I have a very rough design that I put together here, you know, with bend lines and what I want to cut, you know, cut, bend lines, relief cuts. And I think that'll be a nice little project. And as far as the aluminum, I think we're going to keep it simple, and we're going to use some of that low temperature aluminum rod to seal up the edges. We're going to keep it so everyone can do it, and they don't need a, you know, another MIG aluminum welder if they don't already have it. We're going to try to make that work, which I'm pretty sure it's going to work just fine. But yeah, that's the next task. We're going to do some limit switches. I'll order those in. Really pleased with the layout here and the location. This is all good. Everything rolls with the table. I can just get the cords now, roll them up. Picked up a couple of these hooks from Harbor Freight. They're magnetic. They go right on the side. I can roll up whatever wires, hook them right on here. You know, stuff like that. I also got them to experiment a little bit to see if we can do maybe some key holders. You know, just say if you had this in your house, you'd be able to, you know, put it here. Or if you wanted to use this as a key holder, hang it from your wall or something, and then you can put the magnet on there, hang your keys off of it, or, you know, stuff like that. A little quirky stuff. Yeah. And I think we're going to cut some stuff for the machine too. We're going to add some steel on the bottom. Another thing I'm pretty sure we're going to upgrade to, probably before the limits, is these rails here. That top rail being stainless is so much nicer than having the steel. The steel is a lot more maintenance. The stainless steel just stays so much nicer, especially with the water table. I feel like I have to wipe down the steel much more. I keep steel wool around here, right up here in a bag. And, you know, you want to steel wool the rails, keep them nice and clean. If not, they get a lot of smuts on there. This fluid splashes up, especially in the beginning when I had too much air going through the plasma cutter. It really splashed up a lot of water. But now I'm getting a feel for everything, and now I know I can set the machine more towards, you know, the center, and then I will not end up with a mess everywhere, and I don't have to go protecting a whole bunch of stuff, even though I got fire blankets and things like that. But you could see in the previous videos, I had the fire blanket set up here. The floor was all wet. It was kind of just a mess. But this is all the stuff that we're working out. And, you know, you can look around. We just did all that cutting. We really don't have much in terms of smoke. If you get the machine set up right, with the air and the amperage, you won't have a whole lot of mess to deal with. So, glad you guys stuck around. If you haven't liked and subscribed, let's try to build a channel. I don't know. We're going to do some some more cutting. We're going to come up with some more intricate stuff. I really like the signage part of this. Really do. And then we're going to look around. We're going to see if we can cut some parts, some mechanical parts for some things, or we see if we could download something mechanical that moves, parts that we can cut on here. Maybe something reciprocating or like a can crusher or something like that. We're going to cut out some projects. We're going to get some steel moving out of this machine. And I think this is good stuff. Haven't cut quarter yet. 1/8 inch steel is pretty much all I've been dealing with so far. It's not thin enough to where it's going to bend and be flimsy, and it's not too thick to where it becomes too much to manage. But I don't think it would be much of a problem to cut some 1/4 inch. The only thing I would change with the 1/4 inch is the speed. I would keep this tip. This is a 0.9 tip on this plasma cutter at 50 pounds of PSI, of air, excuse me. 50 pounds of air. And it is working perfectly. Another thing we might do is get the regulator that is on the plasma cutter itself and replace that with something with a little more accuracy. The one on there is just a generic, you know, overseas, whatever they slapped on this little Mighty Mouse machine here, which has been fantastic. The duty cycle stuff hasn't become an issue. I'm not cutting, you know, huge signs. But even then, you can always pause the cut and let it sit and then continue to cut. I think as far as I'm concerned, this plasma cutter is adequate for what we're doing there right now. If we need to upgrade it later on, great. But again, for the money, you're not going to beat it. It works great. I may have bad-mouthed it for a second there out of frustration of what was going on with the interference, but yeah, this is a great thing. Like I said, there you go. We got to attack this enclosure next. So I think we're going to fabricate one. I think maybe tomorrow I'll head outside. I'll cut that piece of aluminum in half so we can put it on the table. And it's nice. Having the table this big is really nice too, because you don't have to keep loading material on it. You just put your 4x8 sheet and you literally come up to it and start off at whatever point you want to start off at. Home it, you know, take it to whatever point you want to start, zero out the machine, and, you know, load and go. This is really nice. Really happy with this. We're going to schnazz it up a little bit more. And, yeah, I think we got us a good table on our hands here now. And I hope that everything along the way has helped you guys. And again, if you guys help me out with smoothing out these cuts, appreciate it. We're definitely open to any suggestions. I hope this helps again, guys. Stick with us, like, subscribe, and we're going to do some more cutting. Take care.